This video is for lesson 35-2 about volume of pyramids and cones. The learning goals are to solve problems involving volume for pyramids and for cones. In a previous lesson, we discussed how to find the volume of prisms and cylinders, and there were formulas for doing that. So in this lesson, let's first discuss the formulas for volume of pyramid and cone. Both of them use the formula volume equals 1/3 times the area of the base times the height. So in this formula, the capital B is area of base. If the base of a pyramid is a square, find the area of that square. If the base of a pyramid is a hexagon, find the area of the hexagon. In the case of a cone, the base is a circle, so find the area of the circle. The letter H in this formula is the height of the pyramid or the cone, the distance from the bottom to the top. Skip ahead in the packet till you reach page 515 and find the try these questions. Let's use these as examples, starting with A. The height of a pyramid is 24. That's telling us the value of H. The area of the base is 22. That's the capital B. Find the volume of the pyramid. So start with a formula. Volume equals 1/3 base times height. For capital B, fill in 22. For height, fill in 24. Then multiply these together on a calculator. The result is 176 cubic feet. Remember that volume uses cubic units. Now question B, the volume is 220 cubic centimeters. That's telling us the V to begin with. The base area is 10 square centimeters. What variable is that 10? It's the capital B. What is the height? So we're looking for an answer for H. Write down the formula for volume of a pyramid and then make the substitutions. 220 in for V and 10 in for capital B. The letter H is the one we don't know. Now solve this equation. You can multiply both sides by 3 to cancel the 1/3. That makes 660 equals 10 times H. Now divide both sides by the 10. And you get H equals 66. Now what kind of unit do you need by that? Think about what you figured out. We figured out the height. What kind of unit is used to measure height? That's regular distance units. So just centimeters. Now question C, the slant height is 10. That means that the lowercase l is 10. One side of the base is 12. What is the volume? So we want to find volume. We need the formula V equals 1/3 times area of the base times the height. Now let's substitute any numbers that we know into this formula. Does it tell us the area of the base? No, it doesn't. We know that the base is a square, and we know that one side of the base is 12. But you have to think about this shape. You have a square, and one side is 12. Then so are the other sides. So the length of the square is 12, and the width is 12. What is the area? That would be 144. Now the height. Does it tell the height of the pyramid? It doesn't. It tells the slant height. So let's draw a pyramid so we get a handle on what's going on. The slant height is a line running from the top right down the middle of the side, touching the side at a 90-degree angle. If the entire length of that bottom edge is 12, then just this distance is 6. The slant length running down here, we're told, is 10. The height of the pyramid goes from the top straight downwards to the midpoint of the bottom. Then I'm going to connect from the midpoint of the bottom out to the edge where the slant height touched. Do you see this red triangle? Do you recognize the shape of it? It is a right triangle. The diagonal is 10. This distance is 6, and the height we don't know. We could call h. Let's use the Pythagorean theorem to find h. So 6 squared plus h squared equals 10 squared. 36 plus h squared equals 100. Subtract 36, you get 64. And now the square root, you get 8. So the height of the pyramid is 8. We didn't know the height to begin with, but we used the Pythagorean theorem to find it. Now go 1/3 times 144 times 8. The result is 384 cubic feet. On the next page, you'll see drawings of an oblique cone and an oblique pyramid. If you ever need to find the volume of these shapes, you use the same formula for right cones and right pyramids. There's nothing different about it at all. Just use the formula V equals 1/3 times capital B times H. Skip ahead to number 10. We have the drawing of a cone. We're asked to find the volume. What we have to work with is the radius and the height. So let's use the formula for volume of a cone. 1/3 times the area of the base times the height. Because the base is a circle, the area of the base is pi r squared. And then times the height. What do you fill in for r? It's the 6. What do you fill in for h? It's the 15. We're not going to take the time to type this out, but you would just type this in a calculator and make sure you give the answer with the correct kind of units. Go to the check your understanding, number 11. A container is in the shape of a right cone, and it has a diameter of 18. The height is 7. What is the volume? Think about what you're asked. What's the volume? Think about the shape. It's a cone. What formula do you use? It's V equals 1/3 times capital B times H. Or because it's a cone, it's really 1/3 times pi r squared times H. Next, fill in all the numbers. What do you fill in for radius? Well, it doesn't tell you the radius, but it tells you the diameter is 18. So what's the radius? It's 9. What's the height? It's 7. To find the final answer, you would type this in and push enter. Make sure you give the answer in cubic units because you are finding volume. So let's summarize. In this lesson, we discussed how to find the volume of the pointed three-dimensional objects, which are the cones and the pyramids. The formula is very straightforward. It's 1/3 area of the base times the height.